Hey guys, how's it going? Uh, I am here with you today, and we're taking a look at the bead or corn mark and recapture lab again. My apologies. Again, this was confusing for you. Several of you told me that, and I really appreciate that feedback. And so I'm going to walk through that mark and recapture lab with you in this screencast. We're going to go through the whole thing together so you can follow along on your handout while I am working with you on this screencast. So again, if you watched my other video, I'm going to delete it. If you didn't, then you didn't miss it because it still was confusing. I was giving you instructions how, but like I said, I'm just going to do it for you and then you're going to follow along. But I already have my corn here. Oh yeah, corn. Love it. And I have my corns already marked out. And I know I've already counted my population, did that ahead of time, so that would make this real easy for you. So the whole idea of this is that in different wildlife research kind of aspects, they're going to use mark and recapture lab to determine population size. Things like that help with understanding, for example, how many deer there are in certain areas in Pennsylvania so that they know how many tags they can give out. They do this much more frequently and specifically with elk in Pennsylvania, and they have radio collars that they put on the elk, and that allows them to keep track of the herd size while they're doing different experiments and things. So, um, again, I already have my corns, beads, whatever. They are already marked, and I'm ready to go in this lab. So, first thing, I've randomly selected 20. So I have my package that I already marked 20. So this is the same as if I was trying to estimate the population of animals and I go out and I tag 20 of them. And then I'd release them back into the population because I want them to disperse themselves. And then I'm going to catch another 20. And when I do, I'm going to determine how many of them were the original ones that I had tagged. And that's going to help me get a percentage and an actual number for my calculation so I can estimate population size from that. So in the first trial of the first step 1, 20 catches, we're going to put 20 because that's how many we marked. And then we're also going to put 20 in the second trial because that's how many we're catching twice. So let me catch some here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, sorry you can't see the corns, but I'm gonna count them and I will report the results for you here. Okay, so I caught 5 of them twice. And so that number caught twice goes on the bottom. And then this is just a math formula. So I've got my calculator open and I'm going to do 20 times 20, that is 400, and divided by 5, that's 80. So my calculated population for number 1 is 80. And I will tell you, I already counted this bag and my actual population is 100. So our population estimate was off by 20 in this case. All right, now we're moving on to step 2, which is 40 catches. So we are going to try and see what happens with the same population size. And we're going to catch and mark 40 instead of 20 and see what happens to our population estimate. What is your thought? What is your hypothesis while I'm counting out 40? Sorry, I lost one on the floor. So do you think it's going to be more accurate or less accurate with a count of 40? And if we were doing this in real life, is it going to cost more in resources or time to tag 40 animals than it would to tag 20 animals? Those are the kind of questions that wildlife managers may have to ask themselves if they're using this technique to be able to determine how many animals they might be able to count to get a population estimate. How much money and time they have to count animals, and if they get a reasonable population estimate when they're doing so. There's some great questions that get asked. Okay, so let me count them. So in this trial, we caught 40 to begin with. We tagged them. We put them back in the population. We caught 40 again, and we got 23 twice that time. So we do our math calculation. 40 times 40 divided by 23, and that gets me an estimated population of 70. So we actually went down. Statistically, not always how it is, but we still have a population of 100, so we were off by 30 that time. All right, I'm going to put my corn kernels back in my bag for that one. And that obviously can happen in real life also, that estimates depend on where the animals are in the population that are marked. Are they evenly dispersed? We would hope so, but there are certainly things that happen in populations. Animals die. There might be other factors that cause variation. And so repetition and replication of this type of thing helps to make it more accurate. And generally, more makes it more accurate. So the more that you're going to catch each time, the more accurate going to be. But like I said, in this case, we were more accurate with our 20. That may have had to do with distribution, but can't say. All right, so I'm on my last trial here, 10 corns, and I've already caught them, but I did not get any that were marked in the second time that I caught them. So number caught once is 10. Number caught twice is 10. Or excuse, yeah, and number caught in the second trial is 10. Number caught twice was 0. So really in this case, our calculated population is nothing because we didn't catch any that is twice. So it's not accurate. Actual population is still 100. Our estimate is off by 100 in that case. All right, so hopefully that's better. And again, you can use my numbers, my data right here. We talked about some questions, why wildlife managers or research personnel might be doing this type of activity and some of the challenges they face. And hopefully that helped you understand this concept better. Apologies again for the challenges behind this the first time. I'm learning every day like you are. So you guys have a great day. We will talk to you soon. Bye.